Hi there, and welcome back again to our Grade 12 Geography Cap series. I'd like to thank you for tuning in. And in the previous video, we discussed the general characteristics and the areas where tropical cyclones form and the factors necessary for their formation and also the stages of development. Okay, so if you haven't checked that video out, guys, please do. I'll leave it in the description box and it should appear on the top right corner of this video. Right, so in this video, we are continuing with the series, finishing up with tropical cyclones. So we'll discuss the associated patterns. So looking at the cross section, how you actually draw the cross section. We'll also discuss terms that we did not visit during part one of the tropical cyclone series. Okay, and we'll also look at how you actually identify these cyclones in satellite images and in synoptic weather maps. And lastly, we'll also discuss the impact and strategies that we can implement to minimize the impact that these tropical cyclones we know do pose or do have on the environment, on the humans, on the economy, so on and so on. Right, so let's dive into the video before wasting any time. So start with how you actually can identify a tropical cyclone in satellite images and in synoptic weather maps. Now, these can be confusing, especially your satellite image, because usually you have questions like, in which hemisphere is this particular tropical cyclone? So we'll also discuss that. Okay, so let's look at this, guys. So as you can see, first of all, you can clearly see that in a satellite image, by the way, this was taken from the self study guides in the Department of Education. So if you do not have access to this document, I'll leave a link in the description as well so that you can access it. Okay, it's a great resource, guys. Right, so looking at this, we can clearly see that in satellite images, the tropical cyclone shows a band of clouds. So if we compare a tropical cyclone, compare it to a mid-latitude cyclone, you can clearly see that. Okay, so let's take a look at a mid-latitude cyclone. So if you take a look at a mid-latitude cyclone, you can clearly see that a mid-latitude cyclone has this spiraling, okay, and it has these gaps in between. And as you can see, the spiraling of clouds, and we do not actually see a hole or the eye here. So you can clearly identify this as a mid-latitude cyclone. So I need you to look at the difference between the satellite image of a mid-latitude cyclone and the satellite image of a tropical cyclone. Okay, so let's look at this. So as you can see, guys, there we go. So this band of clouds is actually full. So as we can see, those are our eye walls, okay, that are right next to the eye. And as you can see right over there, there is the eye. Okay, so there is a hole that is at the center of these clouds. Okay, so be able to differentiate between a tropical cyclone and a mid-latitude cyclone in satellite images. Right, what else do we see? Well, we also see that this particular tropical cyclone has a clockwise movement of air. Okay, so look at how these clouds are actually spiraling. They are actually depicting a clockwise spiraling of movement, okay, or spiraling of air. Okay, so this you would say is a tropical cyclone that must have developed in the southern hemisphere. So those are the types of questions that you would get when you are offered or when you are presented with a tropical cyclone satellite image. Okay, so be aware of those questions, expect them, right, and be able to identify this as a tropical cyclone. Okay, right, now what we see here in the synoptic weather map, how you identify the tropical cyclone, okay, especially if it's in its mature stage. This is what you see. We see the eye, okay, the eye sign or symbol really is a huge giveaway. So as you can see, once you can detect or identify this symbol, then you can definitely say that this is a tropical cyclone. Okay, and as you can see here again, guys, you have these weather stations. Okay, I think we should have a video on weather stations. So these weather station models, and they are illustrating a clockwise movement of air as well. So this definitely is in the southern hemisphere as well. So you use what you see in order to deduce, make conclusions. Okay, so we look at the eye. So, and also the tropical cyclone also usually has a name. Okay, so remember we said that tropical cyclones are named based on the order of occurrence. Okay, during that particular season. Okay, this is Geralda, tropical cyclone Geralda. So you can clearly see that this is a tropical cyclone, and if you are not sure yet, you can also take a look at the the general season, or the season in this particular case. So we can clearly see that we have a couple of low pressure cells, and so that means that air is actually rising up. Okay, so if air is rising up, then that must be warm. Okay, so if it is warm, we know that that is the summer season, and hence you see tropical cyclones developing. Okay, so be able to identify tropical cyclones. Look at that eye. Do you have that symbol of the eye? Do you have the name of the particular tropical cyclone? Can you see that? If you are not sure yet, can you deduce that this is a summer season? Okay, so use multiple hints in order to make or deduce that this is a tropical cyclone. So this is how the tropical cyclones appear in satellite images and in synoptic weather maps. Okay, right. So let's take a look at this region. So in this particular cyclone, we are shown this region. Okay, so this region right here actually has a name, and it is one question that is very common, and a lot of students really struggle with it. Okay, so this is an area or a region within this tropical cyclone. Okay, in which you have the strongest wind speed. So it's the most dangerous area in the whole tropical cyclone. Okay, so you would rather be over here than be right here. Okay, because right here is quite dangerous. Okay, so we'll take a look. Let's take a look at why is that, and what do we call this particular area or region in this tropical cyclone. Right, so this area is what we call the active quadrant. It's also what we call the forward left hand quadrant in the southern hemisphere, and it's also what we call the dangerous semicircle. So as you can see, guys, it has multiple names. So I'm equipping you with those terms, all of those terms, so that you don't get confused if they ask about the dangerous semicircle rather than active quadrant, or the forward left hand, or the forward left hand quadrant. Okay, so as we say that, okay, within this particular cyclone there is a region here. Okay, so it's like a piece from a full pizza. Okay, so it's just one region that is the most dangerous, that has the highest wind speeds, that is very aggressive. Okay, so you have to be able to explain why is that. Okay, how does it develop? Okay, because the question usually asks which area is the most dangerous in the tropical cyclone. Of course, you would say it's the active quadrant, or the forward left hand quadrant, or the dangerous semicircle. And usually the follow-up question would be, how does it develop? Explain how it develops. Okay, so this is what you would say. So we say that this area develops when rotating wind direction. Okay, so the rotating wind direction, we're referring to the wind that is within the tropical cyclone rotating clockwise. So it's when this rotating wind direction coincides, okay, meaning which in the same direction. Okay, so it coincides with the major wind driving the whole tropical cyclone. Okay, so I know that is not very clear, so I'm going to try to explain it as much as I can. Okay, so we have this tropical cyclone, this system. So this is the system, tropical cyclone, and within it, it has winds that are rotating clockwise, right? Now, at the same time, this whole tropical cyclone is also moving as a whole. Okay, so it is also moving from east to the west. Okay, so while it is moving from east to the west, within it you also have winds that are moving clockwise like that. Okay, so I need you to visualize that movement. Okay, this is rotating clockwise. Remember, this is a top view, guys. Okay, this is rotating clockwise like that while it is moving, so it's like a movement that's like that. Okay, right? Okay, hope you get me there. So now you have, when we look closely, we zoom in here, you'd realize that in this particular area, okay, so let's look at this area. So right over here, you have winds that are moving this direction, right? Because this is rotating like that. So winds in this particular, in this region, they are moving in this direction. So if we compare this, or if we compare these winds, compare it with the major winds that are actually pushing this whole tropical cyclone towards the west. So remember, you also have winds that are pushing the whole tropical cyclone to the west, right? So looking at that, you are going to realize that these major winds, okay, the tropical easterlies, by the way, the tropical easterlies are moving in the opposite direction as the winds rotating inside the tropical cyclone. I don't know if you get me there. I hope you do. So the winds that are responsible for moving this tropical cyclone towards the west, okay, they are they are moving in the opposite, they're actually moving in the opposite direction as the rotating winds inside the tropical cyclone. Okay. And so as you can imagine, if I'm in this particular region, okay, so if I'm over here, I will not experience as I will not experience the highest wind speeds because I have opposing winds in this particular region. I have winds that are pushing I have major winds that are pushing this tropical cyclone. They are going to the west. And I also have winds that are moving in the opposite direction, which is rotating clockwise, but in the opposite direction as these major winds, which are the tropical easterlies. Okay, so in this region, I actually have the lowest. Okay, so I relatively have the lowest wind speeds. Okay, so this is not as aggressive as the area we are about to depict. Okay, so lowest wind speeds, it's not very aggressive. Now, when we take a look at this particular region now, okay, so let's take a look at this region. So in this particular region, you have winds that are rotating clockwise, right? So we have winds that are moving. These are the same winds that are within the tropical cyclone, moving, rotating clockwise. Okay, so in this particular area, they are moving in this direction, right? Okay, while in that particular area, they are moving in that direction like that. Okay, so it's a continued movement like that. Okay, but we're just isolating this particular area. So in this particular region, if we look closely, you can see that the winds rotating in this area, or the wind direction of these rotating winds, is actually in the same or coincides with the major wind direction. Okay, so the winds that are driving this whole tropical cyclone. Okay, so now you have these rotating wind direction coinciding. So now you have this wind, now you have this rotating wind direction coinciding with the major wind direction. Okay, so as you can see, this would mean that you actually add up those together. So I'm going to add up the wind speed of these rotating winds in this particular area and the wind speed of this of the major winds pushing this whole system, okay, right here. So this means that right here in this region we'll have the highest, okay, so the highest wind speeds in the tropical cyclone are in this particular region, and this region we call the active quadrant, okay. It's the most aggressive, the most dangerous area within the tropical cyclone, okay. So I hope you got me there, guys. So I hope that made everything clear for you, okay. So because here they are opposing, you have opposing winds, then that slows down the wind speeds in this region. Because here you have coinciding wind um, wind speeds or wind directions, and so this means that this is so these add up to form the highest wind speeds in the whole tropical cyclone. Okay, so that's how a dangerous semicircle a dangerous semicircle forms. Okay, so area develops when the rotating wind direction coincides with the major wind driving the whole tropical cyclone. So if you can just explain it this way, you would get the full marks. Okay, so that's it, guys. Okay, so let's move on then. So now we move on. We take a look at the cross section of a tropical cyclone. I had some of you guys really don't understand what's going on here, so I'm going to try and make it simple for you, right? So this is what we call a cross section. Okay, it's also called a transverse profile. Okay, so it's a side view essentially. In the cross section of a tropical cyclone, you have to identify, separate it into regions, and know that each region or each area has a different weather pattern from the other. Okay, so as we know, guys, as we all know, we know that the eye, okay, which is at the center, okay, so let me just try to draw. So let's say this is, okay, try to draw. So it looks something like this. Okay. And due to the band of clouds, it looks something like that. If we look at this, right, so this is the eye. The eye does not have any clouds. Okay, let me do that. So the eye does not have any clouds. This is the calmest region of the tropical cyclone. Does not have any clouds. It has calm weather. It is warm. Okay, it has the lowest wind speeds. Okay, it has the lowest pressure. Okay, so remember this is a low pressure, right, guys? So still know that a low pressure at the center, you have the lowest pressure, right? So as you move outwards, you get the pressure begins to increase. Okay, so the lowest pressure is at the center. Okay, so now what we do know is that, okay, if the lowest pressure is at the center, the eye actually has winds or air that is moving from the higher altitudes descending down towards the lower altitudes. Okay, so we start with the eye and discuss what is happening here. Within the eye, as I'm saying, you have winds or air that is moving from the high pressure that is in the upper atmosphere, guys. This high pressure is in the upper atmosphere. It's not at the surface. It's in the upper atmosphere. Okay. So we have a high pressure there. And then a relatively lower pressure at the surface. There's a low pressure at the surface. And so that means the pressure gradient is created, meaning that now air will move from the high pressure, of course, towards the low pressure. And so in the upper atmosphere, we do know that you have colder air, and this colder air descends down, but as it descends down, it actually warms up. Okay, so as you can see, we went from a blue arrow. Okay, so this is cold air. And as it sinks down, so it sinks down, and as it sinks down, it actually becomes warmer and warmer. It warms up. So the temperature increases. Now you have warm air. Okay. But the thing is, if you are going to warm up air, okay, if air is going to warm up, you are actually going to get rid of moisture. Okay. So if it had any moisture, you're going to get rid of moisture such that it will end up being dry. Okay. So this is what we will talk about with back winds. Okay, so it's similar to back wind. So as the air descends down, it warms up, and we say that it warms up adiabatically. Okay, so we call it adiabatic warming. So that means that the temperature increases with decreasing altitude. Okay, so say that as the air sinks down, it warms up. Okay, so its temperature increases, so it warms up adiabatically. Okay, or you can say it warms up due to adiabatic warming. Okay, so that means that it will be the warmest when it reaches the surface. And so as residents that are living on the surface, we experience high temperatures. Okay, so that means that we record high temperatures. So the highest temperatures that you're going to record are in the eye. Okay, so if I were to draw a graph, okay, in the eye, I would have actually the highest temperatures. Okay, the eye has the highest temperature. So if that's a graph, and as I'm moving away from the eye, guys, I actually decrease with temperature. Okay, so remember now you have, so as you're moving away from the eye, you are actually moving towards higher pressure areas. Okay, so again we go back here. So if I'm moving away from this, I'm moving towards higher, relatively higher pressure areas. Okay, and hence relatively higher pressure areas, we know that high pressure is always associated with cold air, and so it gets colder and colder and colder. Okay, as you move away from the eye. Okay, and because right next to the eye, it's you have the eye walls, which are your thunderstorms, with which are your cumulonimbus clouds. Okay, as you can see, you have huge cumulonimbus clouds surrounding the eye. Okay, and so as you move away, now you have cold air, and so the temperature rapidly drops. Okay, so as you can see, it drops rapidly. Okay, so this means that this is what it would look like if I were to draw it. So let's draw it again. So it would look something like so. The highest temperatures are at the eye, and as you move away from the eye, the temperature actually drops. Okay, so something like that. Okay, so you need to be able to detect that. Okay, one other thing is that you can see that the low pressure is right at the center, but the because of the rotating air that is rotating around the eye. Okay, so that forms a wall, right? So any air that moves towards the low pressure will be forced to rise next to the eye wall, not move into the eye. Okay, because there's that eye wall that is protecting the eye. It serves as a protective layer, and it exerts a force such that any air that is invited towards the low pressure is actually forced to rise up right next or in the eye walls like that. Okay, so it rises up, it cools down, and it condenses. That's why we see this this cumulonimbus clouds right next to the eye. Okay, so the cumulonimbus clouds form due to the rapid rising of air. Okay, so if we would correct this isobars, find out that actually right next to the eye you have isobars that are close to each other. So what does this mean? Remember, isobars that are close to each other, guys, I think we discussed that. We said that that illustrates um, that illustrates a steep pressure gradient. Okay, so due to the steep pressure gradient, air is forced to rise up rapidly, and so now that means you have a lot of um, air that actually is forced to rise up, that rises up rapidly, and forms, of course, those tall cumulonimbus clouds. Okay, so you can only form tall cumulonimbus clouds when there is a steep pressure gradient, and there's a steep pressure gradient as you move towards the eye. Okay, right. So as we can see, guys, there's low cloud cover. There's no cloud cover at the eye. Okay, so there's no cloud cover, so that's the lowest cloud cover that you can get at the eye, because there's no clouds at all. And then you have the highest cloud cover that forms, of course, or you have the highest cloud cover in the eye wall. Okay, so these are the eye walls, which is these cumulonimbus clouds. Okay, that's the highest cloud cover. And then you drop as you move away from the eye, because the pressure gradient gets gentler and gentler. Okay, so now air rises up gently and gently, and it rises up slowly. Okay, so the cloud cover is lowest at the eye, is the highest in the eye walls, and as you move away from the eye, the cloud cover actually drops further. Okay, right. So as you can see, we went from cumulonimbus clouds, and these are the stratus clouds. Okay, so stratus clouds. So the pressure, the cloud cover, we say that the cloud cover is dropping as you move away from the eye. Okay. Now let's talk about the pressure, guys. So what's going on with the pressure there? Well, we do know that the pressure, that's simple. So with the pressure, we do know that we have the lowest pressure right at the eye, and as you move away, the pressure increases. Okay. Okay, so because you have the lowest pressure at the eye, and as you move away, you get rain, you have cold air, and so the pressure actually increases away from the eye. So this is what it would look like. So it will be the lowest at the surface, and you are going to get the highest pressures as you move away from the eye. Okay, like that. Okay, so that comes to the pressure. So the pressure increases away from the eye, guys. Remember, this is a cyclone. Okay, so pressure, of course, would increase moving away from the eye. Okay, so another thing that we have to discuss is the wind speed. So the wind speed really depends on the pressure gradient, and as we said, guys, because the pressure gradient is the highest around the eye or close to the eye, that means the wind speed will be at the highest in the eye wall, and then it will drop. Okay, so that means that when it comes to wind speed is the lowest in the eye, and then the highest in the eye walls. Okay, and then it drops. Okay, because the pressure gradient drops as well. Okay, so take a look again at that. Okay, so pressure gradient, we say that it is the highest right here. Okay, so steep pressure gradient really affects wind speed and also affects cloud cover, guys. These two are almost always related to pressure gradient. Okay, so because the pressure gradient is steep right around the eye, in the eye walls, you'll have the highest wind speeds in the eye walls, and it will drop. Okay, so of course it will also depend on the side that has the active quadrant. Okay, so that will be the highest wind speed, so that will increase there on that side. So that also is a factor there. Okay, so um, so that is how you analyze, how you annotate the cross section of a tropical cyclone and all the different weather patterns, okay, in these different areas. Okay, so you have to know the air pressure. How's the air pressure in the eye, and how is it as you move away from the eye in other regions? The temperature, the wind speed, the cloud cover, guys. Okay. Right, so that's it for the cross section of a tropical cyclone. This is how you draw it. Okay, weather conditions are usually what they ask, okay, on on a cross section of a tropical cyclone. So you can't get this wrong, guys. Okay, so that's it. Let's move on. Right, so let's move on to the impact that tropical cyclones have. So there's mostly negative impacts, okay, that tropical cyclones have. There are some positives, but they are very limited. Okay, so it's really important that you also note what the impact they want you to discuss is on. Okay, so could be the impact on humans, could be the impact on the economy, could be the impact on the environment, it could be the impact on biodiversity. And because we are a channel that strives to make things simple for you, we have actually gathered all that information for you. Okay, so let's take a look. We'll start with the impact on humans and then move on to the economy, then the environment and biodiversity. Okay. So, as you might have expected, of course, when it comes to humans, guys, the first thing that comes to mind is the risk of our lives. Okay, so we lose lives due to the weather conditions that they bring. Okay, and so the first point in your paragraph, okay, should be the loss of lives. Okay, due to flooding. Okay, so a lot of people drown due to floods. A lot of families have lost a lot of family members due to flooding and destruction of buildings. Okay, so remember, these tropical cyclones have very high wind speeds, very aggressive, which can reach up to 300 kilometers per hour. So that is very destructive. Okay, so it can destroy a building that is not prepared, that is not built with materials that can withstand the wrath of tropical cyclones. So people lose lives due to flooding, and they can also lose lives due to destruction of buildings. Okay, by powerful rainfall and winds. Okay, so that's torrential rainfall, guys. That's pouring rain, and those are highest wind speeds. Okay, so we see loss of lives, we see loss of valuable possessions, okay, that can never be replaced. So you might have a very important gift from, let's say, from your grandparents, or a picture or something that is of value to you that you cannot just sell to anyone because it has a lot of meaning in your life. And so you can lose that due to flooding, due to this destruction of your home by these weather conditions, okay, by these aggressive weather conditions, right? So we also see a displacement and separation of family members, okay, because a lot of people get displaced, and some get evacuated, some are taken away by floods. So now you will have family members being displaced from each other, separated from each other. And that's what we see when these tropical cyclones hit. We see loss of jobs due to loss of businesses, farms, industries. Okay. So tropical cyclones do not choose when it comes to destruction. They can destroy any type of building if the right materials are not used. And so a lot of businesses suffer a lot because they lose their capital, they lose everything, their equipment that they used to operate. Okay, so farms lose a lot as well. Industries where we process raw materials, they lose their buildings. And so that means that if the place where you used to work at is destroyed, then you lost a job. Okay, so people lose jobs, so a rise of unemployment occurs now. Okay. We also see that there is a higher risk of waterborne diseases because there's going to be flooding. Now we start to see that these diseases, such as cholera, they can rise and people can be affected hugely by those. Okay. Also see a damage to property. So your home can be damaged, your land can be damaged. Now you have to rebuild your home. Now you have to try and repair your land. So that is costly at the end of the day. Okay. So those are the impacts on humans, right? So let's take a look at the impact on the economy. So when it comes to the impact on the economy, we are talking financially. So for the insurance companies, they will lose a lot because a lot of people will lose a lot of their property. So someone might lose their car, may have their car damaged, their house damaged, and they insured all of those properties. And now think of that on a large scale. A lot of people have lost their cars, a lot of people have lost their land, a lot of people have lost their homes. Okay. And so now everyone will want to claim back the money, of course, that they were paying to insure these so that they could repair them. And so think of the insurance companies now, because they are going to have large claims, they will lose a lot of money. Okay. So when it comes to insurance companies, usually areas that have tropical cyclones, that are prone to tropical cyclones, usually do not have a lot of insurance companies, or you'd find that insurance companies, they are really expensive. Okay. Because they know that large claims can be made over a short period of time. A loss, you also see a loss of businesses. Okay. As we talked about, that loss of businesses, which leads to unemployment. Many different businesses, we are talking businesses in across different industries, they lose. They have their properties damaged. They lose their equipments. um, and so this, of course, would lead to them closing down, and hence high rise of unemployment in those regions. Okay. We also see a damage to land and property. Okay. Of course, that is an impact on the economy. If you were using that land, let's say you were using it to farm, to produce agricultural products, and you were selling it, or maybe you had a business where you were selling property, and so because you lost or you damaged these, then that means that there are high costs to repair this. So this will cost you a lot. Okay. There are high cost of repairs, as I said. Okay. So across different industries, and there's also high cost of medical expenses as well. I should have put that there. So medical expenses as well. Let's write that down. Okay. Will A lot of people will get injured. There's also a negative impact on tourism. Okay. So we have, each country has many tourist sites that it has. But when it comes to tropical cyclones, they can damage almost anything, and it would look very worse. It would not have a good look than it were before. Okay, so should think of, because tropical cyclones can result in mass movements. Okay, so if there was maybe a particular mountain that people across different countries would come and see, tropical cyclones have the power to actually break off that land. Okay, mass movement. So now you went from that, now that tourist site looks like that. And so as you can see, this will have a negative impact on tourism, because you will no longer have tourists coming to your country and spending money in your country, explore these beautiful areas, because they no longer do have that aesthetic to them. There's loss of shipping. There's loss to shipping companies and coastal areas. Okay, because coastal areas are low-lying areas, they really get affected easily. Okay, there's what we call a storm surge. So a storm surge is simply a bulge, a huge bulge of ocean water. So if you live close to the ocean and a tropical cyclone approaches, tropical cyclone is able to displace huge amounts of water from the ocean, and of course displace them to these coastal areas, and hence there's a lot of damage there that we see. Okay, a lot of flooding we see in low-lying areas, which are usually coastal areas. Okay, there's loss to shipping companies because a lot of ships get damaged. A lot of ships lose a lot of containers which contain um, valuable products, okay, that they were planning to sell. Okay, so there's a huge loss to shipping companies which transport goods all over the world. There's a negative impact on GDP. Okay, now because you have lost a lot of businesses, now a lot of businesses do not pay tax. Okay, you no longer receive that tax because a lot of businesses are no longer in operation, because now they have closed. Okay, now let's look at the impact on the environment. The saline intrusion of low-lying coastal land. Okay, so saline intrusion, we basically mean that because you are going to have these storm surges, okay, you are going to have ocean water intruding the coastal areas. Now you have the salt, the soil will be salty, or the composition of the soil or the chemical composition of the soil will be changed. So this affects also the biodiversity of these areas, these coastal areas, okay? Because now the soil has changed its composition. Ecosystems are disrupted, okay, as I said, because now you are going to have changing the soil. That means that the plants that are growing on the soil will have a negative impact, and hence the animals that feed on these, okay, the animals that feed on these plants are going to be affected as well. Okay, because an ecosystem, that's an interaction between living and non-living things in a particular area, in a particular region. Okay, and so that's going to affect the food chain. That's going to affect the interaction, the interdependency that these organisms have with each other. Food chains and food webs will be destroyed. Okay, so that is what I just said. The silting of dams. So when it comes to the silting of dams, mean that the dams now will have a lot of soil particles. Okay, because now there's flooding. Okay, flooding, remember, it drags along with it, so it takes these soil particles along with it, and so it dumps them on these into these um, dams, and hence contaminating them, okay, silting them. Now it's going to be expensive to remove or to reclean that water again. Okay, so silting of dams affects the environment and is costly to repair. Okay, estuaries and riverine ecosystems will be disrupted. Okay, so that's that point, and that is the similar point. Storm surges will cause extensive damage to coastal features. Okay, remember, coastal areas are also tourist sites, and so that also goes on to affect the economy as well. So all of these guys are interdependent. And then the water table will rise. So the water table, that's the highest point of groundwater. So of course, if you have groundwater, the water table will rise because now it's going to rain a lot, and so now that means you are going to have more water in the ground as the groundwater. Okay. It also revitalizes the river system. That means that it re-energizes it, gives it energy. Rivers will now flow at a higher speed. Okay, so that is what we mean by revitalization. Increases groundwater supplies, as I said, so that is water table rising. Water pollution, which can result to waterborne diseases such as the cholera. Okay, people can get sick from that, from the water pollution, water contamination. There's also mass movement, okay, that will occur. So your landslides, your mud flows, your rock falls as well. So that's mass movement. Um, Remember, these tropical cyclones can or are capable of unstabilizing these huge masses of land. Okay, and then the impact on biodiversity. So sand dunes will be blown away. Okay, so the sand dunes that you usually also find in coastal areas, the erosion of coastal areas will increase. Okay, because remember, if you are flooding the soil, you actually remove the topsoil. Okay, slowly but surely. Okay, and so that is erosion. And the topsoil, remember, is critical for the nutrients of the plants, and hence this will affect the plants, so on and so on, the food web, the food chain. Fauna and flora will be destroyed, habitats will be destroyed, okay, by flooding. Habitats and food chains will be disturbed. The salinity of the marine ecosystem will be lowered because now the marine ecosystem loses its salinity, okay, the salt content, because now you're displacing that water into the land. Okay, so it loses some of that salt, and hence, of course, that will have an effect on the environment of these species that live in this marine ecosystem. The destruction of infrastructure. Okay, so I don't think this should be, no, this shouldn't be in this. Okay, so, or actually, the destruction of infrastructure can have an effect. Okay, I think this should have been, yes, the destruction of infrastructure will pollute the water. Remember, infrastructure is made up of chemicals. And so when that building or that road that is made up of particular chemicals fall into the river, that will pollute the water. Okay. And then lastly, the strategies to minimize the impact. What can we do? Remember, we cannot prevent tropical cyclones. We can minimize the impact they have. So the first thing we can do is to monitor the development of tropical cyclones. So if you can monitor them, we mean that we observe them. Are they developing? What is happening currently? Do we have a tropical cyclone that is going to approach a certain country? We have to be prepared so that we can be able to warn people early so that they can be able to prepare. There should be satellite tracking, okay? Satellite tracking that's using satellites to track, monitor the development and the possible path of tropical cyclones, okay? So that you can warn people in these regions that, okay, they should move to other regions, they should be evacuated, okay? There should be early warning systems, okay, so that people can prepare in time, okay? There should be equipment, technology, guys, that allows the government to be able to communicate with its people, okay, early. Should evacuate low-lying areas to protect people against floods. Okay, low-lying areas are the ones that are at risks of flooding. So take these people and animals into higher lying areas to protect them against flooding. Okay, ensure that the infrastructure is of good quality. Okay, make sure that you have buildings that can withstand the high wind speeds and the aggressive torrential rainfalls. Okay, so that you do not lose businesses, lose infrastructure. Okay, keep livestock in barns to protect them against the wind and rain. Okay, so ensure that your livestock is protected from the cold and also the rain, because they can also be flooded. Keep people should stay indoors to protect themselves against flying debris, um, wind and rain. Okay, so this one makes sense, guys. Okay, people should be indoors. There's no one that should be wandering around outside. Good medical care will reduce the outbreak of diseases. Remember, waterborne diseases um, are prone in these times, and hence there should be medical staff that is well prepared, that is well trained to prevent the spread of these diseases, waterborne diseases. The local emergency services should be well prepared to assist. Okay, so you should have a well prepared, well equipped medical team that is able to um, help people prevent a lot of spread of diseases throughout. Okay, so this should be tropical cyclones, guys. This is the end of the tropical cyclone. I've supplied you with the necessary equipment, guys, to ensure that you ace. Okay, you do not just pass, but you ace tropical cyclones. Okay, so hope this was of benefit to you, and I'll see you in the next video.